Hello everyone. So today we'll be solving a LeetCode hard problem. Set intersection size at least 2. So the problem states that we are given various intervals from start to end in the form of a 2D integer array intervals. And now we are given a definition of a containing set. And containing set is an array where like each interval which is belongs to this intervals array should have at least two integers in this nums array. So for example, here we have 1, 3. So since this array has like means this interval has numbers 1, 2, 3. So at least two numbers from this interval should be a part of the given nums array. So here means 1 and 2. These two numbers are part of nums array. Hence this is good. Now for 3, from 3 to 7, at least two numbers should be present here. So here as we can see, we have 4 and 7. So again, two numbers are part of nums array for this interval. So this is all to go. And for 8 to 9, we have 8 to 9 as well here. Hence, we have satisfied the condition for 8 to 9 as well. Hence, this nums array is a containing set. Similarly, this can also be a containing set. For example, this 2 and 3 is present here. For 3 to 7, we have 3 and 4. And for 8 to 9, we have 8 and 9. So hence, this is also a containing set. Now we need to return the minimum possible size of a containing set, and we are given an intervals array whose size can lie up to 1e means 3000 3e3. So for example, here for this given input, we have the optimal output as 5, right? Means this is the output array. Means let's try to create a different means nums array as well. So for example, for 1, 3, let's try to like put the numbers which are at the end. So 1, 2, 3. Let's try to put the numbers at the end in the nums array. So we'll put 2 and 3. All right. Now we'll process this. So since 3 is already a part of the nums array, so we already have a single number. Now since later we'll be processing greater intervals, so let's try to put 7 here. So we'll put 7 here. Now for this interval, no number has already occurred. So we'll just simply put 8 and 9 here. And as you can see, like the size of this is 5. Hence the output here is 5. Let's also like see more examples as well. For example, here we had 1, 3. So again we have 1, 2, 3. So let's try to put the means the values at the end as a part of the num set. So we put 2 and 3 here. Now we have 1, 4. Since like 2 and 3 are already means part of 1, 4, so we have already put two numbers from 1 to 4 interval. Hence this is also specified. Now we go to 2 to 5. Again we see like this 2, 3 belongs to 2 to 5. Hence this interval is also satisfied. Let's go to 3 to 5. As you can see, like this 3 is already present, so we can either put like 4 or 5 here. So either 4 or 5 will do, and like this output will be a complete set, means containing set, and hence the output here is 3, the minimum possible size. Again let's see more examples. So for example, here we had 1, 2. So again put all means the last two values of the end as part of the nums array. So we put 1 and 2 here. Then we have 2, 3. So since 2 is already a part, so we put 3 here. Then we see for 2 to 4, both 2 and 3 are part of this, so this is done. For 4 to 5, no value is already present, so we put 4 and 5. So then we can see that 5 is the output for this inter for this input. Now let's try to run for this given example. So we have 1, 2, 3 here. So again put the last two values as part of nums. All right. Now for 3 to 7, since 3 is already present, let's try to like put the values in the end. So we put 7 here. Okay. Then for 5 to 7, since like it only has 7 as a part of it, so we can put either 5 or 6. So let's put 5 here. And then for 7 to 8, we have means 7 is already part of it, so we can put 8 here. Now you might have seen like when we are creating a nums array here, the all the arrays that were being formed were in increasing order. But in this case, the array is not in increasing order. And why this is the case? Because here this means this is a more relaxed interval as compared to 5 comma 7. So means two intervals, a to b and c to d. So here b is the same as d, but since a is less than c, that means like a to b, suppose this is this a to b, then c to d is like this. So this is more stricter, and we are handling the more stricter one, means later on. Means we are first handling the more relaxed one, and then we are handling this 5 comma 7. So that's why like we got an array of size 5, while the output means optimal output for this should be 4. How it will be 4? If we try to handle this 5 comma 7 before 3 comma 7. So if we try to process it in the order like 1 3, then 5 7, then 3 7, and then 7 8. So we'll put 2 3 as a part of this. Then we have 5 7. So we'll put what? We'll put, since both are like means 5 is greater than the last value, so we'll again put the means the values at the end as part of this answer. So we'll put like 6 and 7. Okay, then we put 3 7 here. So again like we will see like this is already a part of the answer, so we'll put, and then for 7 8, since 7 is already present, so we put it. So we see like if you process it in like process the more stricter intervals first, then the values for the means relaxed intervals are already part of the given nums array. Hence we do not need to like randomly assign 5 or 6 here. The output was 5 only, but we see like if we handle the more stricter intervals before, then we can like more relaxed intervals will already be present in there. So this is one observation, and another observation you will see like in all the inputs here, the array is means the pairs are given in a sorted order only, right? Here also like it is sorted, and here also it is sorted. Now which means sorting it on the basis of what features would be optimal. Either we sort it on the basis of start points or end points, which is feasible. So if we like sort it on a means basis of start points, so let's see like we get uh, 1 6 1 uh, 3, and then uh, suppose 1 4, and then 2 3. So in this case, if we try to like put values, then we'll put values 3 and 4 in nums initially, because these values lie on the far end, and then we when we need to process this, we need previous values. Means since 2 is lesser than this end value, we'll need to put 2 here as well, right? So this is means not good. But instead if we like sorted it on the basis of endpoints, then the intervals would have been like 2 3 and then 1 4, right? Now we can simply put 2 3 as part of nums, and since like it is sorted on the basis of endpoints, this 2 3 is already contained in 1 4, and hence will be means easily able to give 2 as the output. So two means two observations that we have made is, first, sort on the basis of endpoints, and second observation was to handle the more stricter intervals first. So if endpoint same, process means more means stricter intervals first, stricter or smaller intervals first. That means if we have a b and c d, a b and c b, so if a is less than c, so we'll first process c b, and then we will process a b. So now we know how we'll be sorting the given intervals input based on these observations made. So how we'll be sorting it? We'll be sorting it like suppose we will be sorting it we'll be sorting it from start till end. And what will the comparator function? It will take two vectors, suppose A and B. Okay. Uh, Now how the comparator function would look? Uh, for example, if we have the endpoint as same, means A of 1 is the same as B of 1, then what we will return? We will return that the will handle the greater values first, like we will handle C first then A first. So we return A of 0 greater than B of 0, right? And else we'll just simply sort it on the basis of endpoints. Okay, so this is how we will be sorting this. Now once we have sorted it, how what we are doing initially is put the values which lie on the far end, means far right. Those two values will be putting it as part of our nums answer. So what we are doing here is, suppose we take two values, int second as air of 0 0 minus 1, means air of end minus 1. So it will be air of 0 1 minus 1, and the first value was air of 0 1, means the end, right? And now how will you process? We'll start from the end, means first index. Now we have two cases here. Suppose current is, start is air of I0 and end is air of I1. Now there arises two cases. First is like start is greater than first. So these were the two values chosen in last two. So this was the two values, second and first, which were chosen for the last interval, right? Now for this current interval that we are handling, if start is greater than first, that means a new interval is being formed. So we will not be able to use both of these values. So if start is greater than first, what we will do? We'll simply like again mark the start as, if start is greater than first, we'll simply make the second value as n minus 1, again the far values on the right, and the first value as end. And since we have introduced two new values, so let's maintain a result variable in result, which is initially 2, because we have used these two values as part of our nums answer initially. And here we'll be increasing result by 2, because we have introduced these two new values as part of our result. Now comes the else condition, where start is less than or equals to first. That means like here we have second to first, and now the new start is something like this, right? It is less than or equals to first. So we need to see like whether we can use this second value as part of our means this interval or not. So we need to, means if we are not able to use this, then we need to update this second value to this, and we'll update this first value to the end. This is what we do. So I hope like you get what we are trying to do here. So what we'll do, we'll check if like start here is greater than end. That means we'll not be able to use use the second value here. Start is greater than second. This start is greater than second. That means we'll not be able to use second as part of our current interval. So what we'll do, we'll mark the second as the first, means move second to here, and move first to the end of given interval. And since we have introduced one new value, the means end here, so we'll increase our result by 1. And finally, we'll be just simply returning the result. So this is what we'll do. We'll just sort it on the basis of endpoints, and if the endpoints are equal, we'll means process the greater start points first, and then we'll follow this simple algorithm. Like if we have an interval, a to b, what we are trying to do is keeping these as part of our answer, so that the newer intervals which are lie in the range can reuse these as part of their complete set. So this was the approach, means a greedy approach for this problem. And we can see, like since we are just sorting it, so the complexity of will be of the order of n log n only. And yeah, and the space is constant. So let's see like the overall code also here. So we just means sorted the given array, and if the endpoints were equal, we means processed greater start points first. Otherwise we just simply sorted it on the basis of endpoints. Now the second value was n minus 1 and n, and if start is greater than first, that means this was second, this was first. So if start lies this start comma n, then means we cannot reuse these values, hence we'll update result by 2, and again mark second as n minus 1 and first as n. Okay, so that this becomes a new interval. And now for newer values, if a new interval appears like this, we can reuse these values. And if like interval lies like this, start to end, that means this start is greater than second here. So we'll just update this second with first, and we'll mark this first to um, point to end. And since we have introduced this end as a new value, we'll update our result by 1. Like I hope you get the logic of this n log n approach, and let's try to submit it as well. Yeah, like it beats most of the runtime. So yeah, I hope like you get the greedy logic that we are trying to follow here. We just like try to dry run on most of the test cases given here, and then we observe like which means sorting it on the basis of what feature would be optimal, whether a start point or end point. And then once we derive the result, we like try to greedily make the nums array here. So I hope like you get the intuition here, and if you have any doubts, feel free to comment down. Thank you for watching.